Now we're going to check out a couple applications. So first of all, Igor traveled a distance of 3x cubed plus x squared miles for x squared hours on the Gulf Coast Freeway. Find a binomial that represents the speed that she traveled. All right, so basically we have this distance and we have this time, right? Hours. And so what's the relationship? We know that distance equals rate times time, right? And we're trying to figure out the speed, right? So we know the distance, 3x cubed plus x squared. And we know the time. So we could do distance divided by time to find rate or the speed, right? Speed is also known as rate. But, and we definitely know how to do that. We could just divide both sides or both terms by x squared, right? We can distribute that x squared. Or, we can start with this and then distribute. But let's use factoring. So I know that x squared is the time, right? So I want to figure out what multiplied by time equals the distance, right? So if this is the time, then I can factor that out and see what's inside here, and that'll be the rate, okay? So if I factor out an x squared, basically that means I'm just dividing it by each of these terms, right? Which is what we just talked about doing. And so 3x cubed divided by x squared is going to be 3x. And x squared divided by x squared is 1. So if this is the time, then that means this must have to be the rate. So our answer is 3x plus 1. So speed equals 3x plus 1 miles per hour. Because we're talking about miles and hours, right? So our rate, our speed is going to be in miles per hour. All right, so that's a way we can use factoring to in an application here. And there's of course other ways we could do that, but this is one way to use factoring. Here in our other example, we have an area situation. So we know the area of a rectangle, which is length times width, right, of a garden is 3x squared, or 30x squared, minus 45 square feet. And the length is 15 feet, so that's L, right? Then what binomial represents the width? Okay, so once again, if we list the area, then we know it's length times width. So if I have the length is 15, then I can factor that out of this, and whatever's left over will be the width, right? If this is the length, then whatever I get as for my leftovers will be the width. So let's do that. So I'm basically going to just divide each of these by 15 mentally or on paper. And so 30 divided by 15 is 2, and then the x squared comes down, right? Negative 45 divided by 15 is negative 3. And that's it. So the width is 2x squared minus 3. All right, and don't forget your units. Our area was square feet, and our length is feet. So width is going to be feet, right? Width is one-dimensional. All right, so that's how we can use factoring to solve some application problems. And this works with area and rate, of course, because we're given the product, right, the answer to a multiplication situation, and we know one of the factors, and so we're trying to find the other factor, right? So we can factor out one to find the other.